So our next question is the 0-1 knapsack problem, and it's a very famous problem of dynamic programming, and in fact it's the first problem that is taught in the dynamic program class. So given a knapsack or a bag of maximum capacity M and weights W1, W2, W3 till Wn and benefits W1, W2, W3 till Wn, find which weights to choose so as to maximize the benefit. That is, a thief, let's say he goes with a knapsack into our house and he finds some objects, n objects of size weights W1, W2, W3 till Wn, and they have their benefits or price B1, B2, B3 till Bn. And now you cannot divide an object, you cannot take a fraction out of it. You have to either take it or you have to leave it, and my maximum capacity is M, so which one should I use so as my benefit is maximized? So for example, if the maximum capacity is 5, so I can take these two weights, so it will become 5. So W1 and W2, if I choose, my benefit will be 3 plus 4, which is 7. If I just take the last object W4, which is of weight 5, so my benefit is 6. Otherwise I can take weight just 4, which is W3, and I will get a benefit of 5. So we see that, okay, the best benefit that we can get here is taking W1 and W2 among these choices. So how to solve this problem? That's the question. So given weights W1, W2, W3 till Wn, and we have benefits B1, B2, B3 till Bn. So our aim is to choose those objects such that the sum total is less than the weight maximum weight M that is given, and we should also be gaining the maximum benefit. Okay, so let's represent x1, x2, x3 till xn as Boolean variables, and it is either 0 or 1, which means if x2 is 1, it means I have taken the weight W2, and if it is 0, I have not taken the weight W2. So our benefit will be what? It will be xi bi, I is equal to 1 to n, and total weight will be xi wi, I is equal to 1 to n. So this is an optimization problem. And what we need to do is that we want to maximize the profit. Okay, maximize the summation xi bi, and constraint is that summation I is equal to 1 to n, xi wi should be less than equal to w. Okay, so this is the case. So how to solve this thing? So let's see. If I take, so basically I'm taking any subset of this. So one brute force algorithm will be to try all possible subsets, isn't it? So I will try all the possible subsets. So there are basically, I can take NC0 plus NC1, nc2, which is n choose 2 till n choose n. So these possible ways I can choose. So there are 2 to the power of n possible ways of taking the subsets, but and then checking, okay, for which one there is the maximum benefit. But the order of this algorithm is exponential. Okay, so it's not that much recommended. So what to do? So what we see is that we can choose any of the subsets. So we will try to solve this problem using dynamic programming. So two things are very important for dynamic programming. One is optimal substructure. So optimal substructure, that means the main problem can be solved using the optimal subproblems, and another is the overlapping subproblem. Okay, so this is the overlapping subproblem, which means I'm solving the same problem again and again. So what happens? We can make a bottom up table and solve this problem. Okay, so let's try to see the solution. So what we do is we represent benefit I comma w is equal to maximum benefit I get by choosing weights till ith item. So I will be choosing only from the first I items, and maximum weight is w. I cannot choose more than that. Okay, so this is the definition. So now let's try to see what happens. So we say BIW. So this is basically benefit of choosing from till ith item, and maximum weight, that can be w. So this will be equal to, so if I'm like I have the items are, so w1, w2, w3 till wn, and the benefits are bi, b1, b2, b3 till bn. Okay, so if the ith item is the weight of the ith item, that is, it is greater than, so wi is greater than m, which is the maximum capacity, then I cannot choose that item itself because it will be more than the capacity of knapsack. Then I can directly write this is equal to b of I minus 1 comma w. Okay, if wi is greater than m. Let's see, otherwise what happens? I can choose the ith item or I cannot choose. So if I not choose the ith item, that means what? I will be only choosing from the I minus 1 items, and weight will be w. Okay, but if I'm choosing the ith item whose weight is wi, so what it means? So I will be getting the benefit b of I because I am choosing the ith item, but now my weight that I can take in the knapsack is not w, because I have already taken wi weight. So my weight will be now w minus wi, because wi weight is already taken by choosing the ith item. So I have to get the maximum benefit from the I minus 1 items, but the weight should only be w minus wi. So these are the two options. This tells that I'm not choosing ith item, not choosing ith item. This is choosing. I'm choosing the ith item. Okay. So this way, but now if there are two possible choices, so this is basically now max of this. Okay. And we know that, okay, b of 0 comma any w will be 0 because I'm not choosing any item, so this will be 0, and b of any I items if I choose but weight is 0, this will also be 0. So this is the recurrence relation, and we will try to see now if there is one example that we take a small example. So like we had taken, so weight is given 2, 3, 4 and 5, and the benefits are 3, 4, 5 and 6. Okay, so if this is the case, so let's see what can be done. So now we said that, okay, we will make bi comma w where I is from 0, 1 till the number of items n, and w is 0, 1 till maximum weight m. So we construct a two-dimensional matrix or a table. Okay, so let's construct. So here we have n is equal to 4 items are there. So 4 items are there and maximum weight is, okay, so n is 4 and maximum weight is, that is given is 5. Okay, so it means what? We will construct a table that will be of size, so I can have 0, 1 till, so this will be 0, 1, 2, 3, 4, and this can be, maximum weight can be 0, 1, 2, 3, 4 and 5. So this will be a 6 into 5 matrix. Okay, so what we will do is, let's construct it. So this is I is here from 0 to 4, so I will have 5 rows. Okay, so let's draw the table again here. So it will be something here, not a very perfect table, but okay. So this will be I is from 0 to 4, so I will have 5 rows here, 1 row, this is 2 row, 3 row, 4 row and 5 rows are there, and weights I have how many? 6. So weights, so this is 1, 2, 3, 4, 5 and 6. So I write here, so this is my I, this is weight, so this is 0, 1, 2, 3 and 4, this is 0, 1, 2, 3, 4 and 5. So now when I have to fill this, so basically my problem is B, so 4 items and my maximum weight is 5, so this 4, 5 is my answer, and I will move horizontally, that is in bottom up fashion. So first I know that, okay, if B 0, any W is 0, because I don't have any item at all. So let's fill the table fast. So these are all zeros, and B any I, if 0 weight is there, this will also be 0. So this is fine for us. So now let's proceed further. Okay, so now we see what is B1 comma 1. So B1 comma 1 means what? I am taking the first item, that maximum weight should be only 1. So I see that, okay, because the first item is greater than 1, so here also it will be 0. So B1 comma 2. So now weight is 2 and we see that, okay, I can take this first object because I am allowed capacity of 2 and my benefit will be 3. So I go further, weight benefit of 1 item and weight 3. So 1 item and weight 3. So I can only choose now the first item. Okay, only 1 item is there, and here also the benefit will be 3. And again benefit 1 comma 4 will also be similarly 3, because I can only have 1 item here even if I have capacity 5. So I can choose just the first item, weight is 2, and it will be giving profit of 3. Okay, so let's make some space for ourselves. So now what we have to do, we have to calculate some other values. Okay, so we will try to calculate those, and how we will do, let's proceed further. Okay, so what now we have to do, I try to find B of 2 comma 1. So it means what, I can take now from 2 objects, first and second, but maximum weight is 1, so there is 0. Then I have B 2 comma 2, that means I can take a weight up to 2, which is now, so I can take this first object, I cannot take the second because it is weight 3 greater than the capacity. So my value is 3, B 2 comma 2 is 3, B 2 comma 3 is, now I can take weight till 3. So it will be now maximum of, I can take B of, that is I can leave the second item, so 1 comma 3, or I can choose the second item, so it will be B 2 comma 0 plus the benefit of the taking the second item. Okay, so B 2 comma 0 we have already calculated, it's 0, so this will be 4, and 1 comma 3 also we have already calculated, 1 comma 3, so this is 3. So 3 and 4, so 4 is larger, so I will choose 4. So similarly B 2 comma 4 is also will be 4, and B 2 comma 5 is, again we can only choose from the, so B 2 comma 4, let's see. So B 2 comma 4 is basically, it will be what, so I can choose from the first 2 and maximum weight can be 4. So again this will be 4 itself. Okay, and let's take B 2 comma 5, it will give us some insight. So B 2 comma 5 is equal to what, so I can, so now the second weight, second item, so WK, I can either have max of B 1 comma 5, which is B 1 comma 5 is 3, or B of 2 comma, so if I am taking the second object, so it will become 5 minus 3, so 2 plus the benefit of choosing the second one, which is 4. So B 2 comma 2 is, we see it is 3, so this is 3 plus 4 equal to 7, so max of 3 comma 7 is 7, so we will get a maximum benefit of 7. Okay, so this was a very good case where we could understand the recursive equation. Okay, so we will take a further few examples and let's try to construct the complete table. Okay, so we will try to fill the next row, and that is what b of now 3 comma 1. So 3 items we can take, but weight is just 1, so there is no item, so it will be 0. B of 3 comma 2, weight is maximum is 2, I can just check the first item, so it will be 3. B of 3 comma 3, so now I can take up to 3 items. Okay, but the maximum so I can take up to 3 items, but the maximum weight should be 3. So I can choose from among these two, so I will choose the second item and maximum benefit will be 4. B of 3 comma 4, so now let's see b of 3 comma 4. So let's try to calculate this value. So this will be equal to max of b of 2 comma 4. If we don't choose the third item, it will be equal to b of 3 comma, if I am choosing the third item, so third item has weight of 4, so this will become this plus benefit of the third item is 5. So b2 comma 4, we see b2 comma 4 is 4 and this one is 0 plus 5, so equal to 5. So this will have a benefit of 5